This is wood, and around it there is air. That means oxygen. So it should react with the oxygen to produce carbon dioxide and water. But it's not reacting. Why is that? It will react if I do this. See that? It's now burning. Why is it burning now? But it didn't burn before. It didn't burn before because there was oxygen and there's wood, everything is present, but the reaction was not spontaneous. So I had to give some heat to make the reaction possible. On the other hand, if you take sodium hydroxide and hydrochloric acid and you add them together, you'd see that instantaneously it reacts with each other and it will produce sodium chloride and water. So that reaction is spontaneous. But the question is, how do we know whether a reaction is spontaneous or not? To find that out, we need to use the equation delta G is equal to delta H minus T delta S. This is something new for you, right? This is called Gibbs free energy. Gibbs free energy is equal to delta H minus T delta S. Here delta H, you know that is enthalpy change of the reaction, T is the temperature, and delta S, in previous video I discussed that, is the change in entropy. Now this is the interesting thing. If the value of delta G is less than 0, that means it's negative, then the reaction would be spontaneous. And if the delta G is more than 0, that means positive, the reaction is non-spontaneous. The reaction will not happen itself. You need to add something, give some heat to it, then the reaction would be spontaneous. Now, forget about chemistry. Let's look at mathematics. How can you make delta G negative? If the value of delta H is negative, if the value of delta H decreases, the delta G decreases. So, if you decrease delta H, the spontaneity of the reaction will increase because delta G becomes more negative. Okay, now, if you increase T, what will happen? Think about it. If you increase T, if the value of delta S is positive, if you increase T, the value of delta G will decrease. So, if you increase temperature, the spontaneity of a reaction increases. For example, like what I did here, I increase the temperature and the reaction, it happens. It reacts with the air. But when the value of delta S is positive, only then if you increase temperature, delta G will decrease. Reaction becomes more spontaneous. Now, if the value of delta S is negative, then if you increase temperature, delta G will increase, not decrease. So to make it spontaneous, you need to decrease the temperature. This is something that I have written here. If delta H is less, if you make the value of delta H less, the value of delta G will also decrease. It will become more spontaneous. If you increase temperature when delta S is positive, the delta G will decrease, making it more spontaneous. Likewise, if the temperature decreases when delta S is negative, the delta G will also decreases. So here's the situation. If you, generally speaking, if the reaction is delta H is negative, the value of delta G decreases, so the reaction becomes more feasible. If you increase the temperature when delta S is positive, reaction becomes more feasible, more spontaneous. And when you decrease the temperature, if the delta S is negative, then the reaction becomes more spontaneous. I hope it's clear from the syllabus. In your book, it's really presented in a complicated way. You don't have to do that because in syllabus it is written. They don't have to worry about delta G of the system or like that because it's not important. The most important thing is whether for a reaction you will have to solve this equation, find whether delta E is negative or positive. Now, as for past paper, there would be two challenges that you will face. Number one is if the value are given, temperature is given, delta H is given, delta S is given, and they ask you to find the value of delta G and predict whether the reaction is spontaneous or not. How do you do that? Here's the challenge. Delta S, the value of delta S that they will give you is not in kilojoule per mole. It is in joule per Kelvin per mole. So you need to convert it into kilojoule per mole. This is really, really important. Let me show you an example of that. Let me take my pen. I'm sorry, I'm using this rag instead of a black of an eraser. Say the value of T is given at 25 degrees Celsius and delta S is given as 25 joule per Kelvin per mole, and the value of delta H is given 33 kilojoule per mole. There's the question, there's the challenge. You need to convert the temperature into Kelvin. So you will add 25 plus 273. That means it will be 298 Kelvin. 298 Kelvin. Just add 273 with the degree Celsius. Now this joule I told you earlier, you need to convert it into kilojoule per mole. So you're gonna divide with 1000, right? So it will be 0.025 kilojoule per Kelvin per mole. This value is okay. You just put the values here, put the values here, put the values here, and you put the values here. This is how you would find the value of delta G. If you find the delta G is negative, then it's spontaneous. If the value of delta G is negative, then it's not spontaneous. Now, another question that may come in your past paper. That is, at what temperature? You'll be given everything. You'll be given this value. You will be given this value. Okay? And they'll ask you, at what temperature the reaction will be feasible? At what temperature the reaction will be spontaneous? Sorry, not feasible. The reaction would be spontaneous. At what temperature? That's the question. Now, delta S is given, delta H is given, but they want you to know the value of T. At what temperature the reaction will be feasible? Here's the thing: if they ask you at what temperature the reaction will be feasible, would be spontaneous, you need to consider at that point that value of delta G is 0. So delta G is equal to 0, and you put the value there. Delta G is equal to 0, delta H is equal to that, delta S is that, and then you find the value of T. So that means the T would be delta G minus delta H, delta H minus delta G divided by delta S. You just put the values here. Put the value delta G as 0. Now you may ask, sir, why would I think it's zero? It's zero. Because zero is at a point where something started to become negative, right? You need to pass that barrier of zero to become negative. So if I can find out the point that at this temperature, at this point, the reaction should be feasible, should be spontaneous, I need to put the value of delta G as zero, because that's the point where it starts to become negative. You can ask, sir, I could have just said delta G equal to -1. Yeah, we can do that, but that's not the absolute barrier, because it could have been 0 minus 0.000001. That could be also feasible. So the best thing is to assume that delta G is equal to 0. Then we find the calculation and find the value of T, and you find the temperature at which the reaction would be feasible. For example, if they can ask you that this matchstick, it is not feasible, it's not spontaneous, but if you want to make it spontaneous, make the reaction happen, at what temperature it would happen? Delta S is given, delta H is given, delta G you assume it's 0, and T you find the T. If you find the T, you will know what temperature it will produce fire, right? Now you can say, sir, you just added fire there, that's why there was no. If you see some survival videos where people make fire, they don't use just fire to make fire. They also use friction. They take something and do the friction, and when temperature is enough, then the heat is produced, right? And then the reaction becomes spontaneous and there's fire. I hope it's clear now. Allah Hafiz.